Alright, now we're doing 7Q cats in hats. This is by 16 sheep, and 84% of the people like it. So the cat in the hat has cat A under his hat, cat A has cat B under his hat, and so on until Z. The cat in the hat has 2 million the cat in the hat is 2 million cat units tall. Each cat is 2.5 times bigger than the cat underneath their hat. We're going to find the total height of the cats if they are standing on top of one another. Counting starts from the cat in the hat, and n equals the number of cats, and we're going to fix it to 3 decimal places. Okay? So basically right here, we're going to start the old-fashioned way. We're going to do a for loop, but first let's declare some variables. Let's say let the first cat equal 2 million. All right? And now let's let result equal 0, right? So let's do a for loop for let I equal 0, minus equals 0, while I is less than or equal to in, we'll say I++. All right, now we're going to say result plus equals, and then we're going to say first divided by 2.5, and then we're going to do it to the ith power. All right, so the first one's going to be 2.5 to the 0, which is going to be first divided by 1, thus making it 2 million. Then the next one is going to be first divided by 2.5 to the 1 power, so just whatever that is, and then divided by 2.5 again, and then again and again and again, and you know how that works. So we're going to say return result. And the thing is, we got to do it in this style too. So the big hint right here for that is fixed to 3 decimal places. We're going to be using the, if you haven't heard of it, the toFixed method, which formats a number using fixed point notation. So basically we put toFixed and then a number in, and then it will make a string with the amount of decimal places, with this amount of decimal places. Hopefully you get what I'm saying. Anyway, the thing is, you got to remember the return value is always a string representing the given number using fixed point notation. So we don't even have to convert it to a string or anything. We just say result dot toFixed 3, like that. Now let's test it out. Just like that, it works. Let's make sure there's no tricks. Attempt it. All right, real good. So let's comment this out, because there's another way to do this. There's a few ways to do this, but there's one more way we're going to do it. And so we're going to come over here and we're going to make concise syntax. We're going to say const height equals in, and then an arrow right here. All right, and then we're going to do a console.log so we can test while we go. All right, and then right here we're going to start by saying array.from. And if you don't know about this array.from method, it's the static method that creates a new shallow copied array instance from an iterable or array-like object. So the syntax we're going to be using for this one is going to be the array.from, and then we're going to have the array-like thing here, a comma, and then we're going to have this little thing full of arguments. It's going to have an element and index, because as you remember, we were doing the index over here, so 2.5 to the indexed power basically. So we're going to be doing that, and we don't need an element, so we'll just use the underscore for that. And so but the thing is, what's the array-like thing? So down here, we're going to be using this as the array-like object. Let me show you. It's going to be this right here. So we're going to have these curly braces right here, and inside of them we're going to have a length, colon, and then in, but we're going to do in plus 1, because as you remember, it's less than or equal to. So we're going to say from curly braces length colon in plus 1, just like that. Then we're going to have the comma, we're going to have the parentheses, We don't need an element. We will need an index. And then we're going to have an arrow right here. So for the expression, it's going to be just like this one. We're going to say 2 million divided by 2.5 to the indexed power. All right, let's test that out, see what it looks like. All right, so now we've got this. So now all we got to do is add all these elements together. We're going to do that using the reduce method. If you don't know about that, the reduce method executes a user supply reducer callback function on each element of the array in order, passing in the return value from the calculation on the preceding element. The final result of running the reducer across all elements of the array is a single value. And perhaps the easiest to understand case for reduce is to return the sum of all the elements in an array. So that's what we're going to do to return the sum of all the elements. Is we're going to use this syntax right here. Just the main one. So that array we already made, dot reduce, and then we're going to have inside of these parentheses, we're going to have the accumulator and the current value, and then we're going to just have the expression, which is going to be, well, I'll show you. So we're going to come up here, and since we don't have any room, we're just going to say enter, come over to this period, and say dot reduce. And then we're going to have accumulator right here and current value. And then just like this, and then we're going to do accumulator plus current value. So basically the accumulator is going to start off with the 2 million with this one right here. And then it's going to add this one, and then it's going to add this one, and then it's going to add this one, this one, this one, this one, this one, all to the accumulator. And it's going to come out looking like this. And all we got to do after that is say, we'll keep it on 2 lines. Dot toFixed and 3 like that. So let's test it out. Come on now. Oh yeah, row fixed. Come on now, row fixed. Dude. All right, cool. Here we go. And it looks like that. Looks like that. Let's take this out of here. Get rid of this one. Test it out one more time. There we go. And attempt it. Nice, and submit it. All right. So you see this first one, it's basically a math formula, which, cool. I'm not into that. I didn't want to think that hard. But they did 1 minus 1 over 2.5, whatever they did. I don't even really understand what's going on right here right now. What's in? Anyway, I don't really understand what's going on right here, but it's a math formula that seems to work. And then this one right here, it's basically what we did, but they made 2 steps out of this 1 step that we did, and then another step right here. I don't know. I don't really know what's going on there either. And then here's something. Did we do it this way? Oh, we could have done it that way. No. We did it a different way. Anyway, so you just keep going down here. Let's go over to mine. Just me on this one. Best practice in my opinion. Very much like it. And we'll see you next time.